So here's a simple little project you can do, especially for young children. It really gets their fascination into electricity and electronics and that sort of thing. And basically you can make this project as hard or as easy as you want to. And in this video I'm just going to use an already pre-bought amplifier here, but you can go to the extent of building your own simple mono amplifier with a just a handful of components really, and you know, make it that little bit more difficult. But basically what it consists of is a small amplifier and a pickup coil similar to what you would find on a guitar. These you would normally see in old-fashioned films where, you know, where people are listening on telephone conversations, because what you would do is put this on the outside of a old style telephone, and you could pick up the conversation and record it. This one I've already used in a project in the past. It originally came with a jack plug on here, but you really need that. This project doesn't work with a normal microphone. Now I'm building this around this little amplifier here. It's an amplifier that I was given. It's basically a poor man's hearing aid, and you put some headphones into the jack here and then you can control the volume. It's also got a treble and bass on this, but I'm not going to worry about that too much. I'm just going to leave those presets somewhere in the middle and not worry too much about them. So I'm going to remove it from this case. I'm going to put it all into this project box here, and I'm going to override the on-off switch and the volume here with this potentiometer here and this little sliding switch here, and I'm going to have the output coming to a simple speaker, just one speaker. You don't need to have it stereo. I've got two speakers here. I've got this slightly bigger one here, and I've got a much thinner one here if I need to use that if I'm running out of space. So what is nice about this amplifier, it just uses a 1.5 volt single AAA battery here. Some amplifiers use a 9 volt, you know, the brick type battery, or maybe a couple of AA batteries, but this is just a low powered amplifier, so it's really nice to work with this. I don't have to worry about a much bigger project box. Now I can't find any screws on this, so I'm presuming it's just plastic tags. Just going to work myself my way around the sides here to unclip it, but of course first remove that battery. And what's nice about this, I'll probably be able to keep the battery holder here. I'll just cut this away from the outer casing. I've got a couple of battery holders here in the lab, but it just makes it a lot better, less components to purchase if you're going to build something like this. So I'll just cut that away from the board there. So this kind of video, I've said previously in other videos, I really like working like this. It's nothing planned, and what you've got to do is try and plan 3 or 4 steps ahead when doing something like this. And now I've got the circuit board out, we can take a closer look at this. And first thing I notice is all these caps on here. There's a lot of caps there, and we've got the microphone here and a op amp chip there, so there's a lot of components on here as well. And basically for a simple mono amplifier using a op amp chip, you can do that with the chip and probably 2 or 3 components. So all these components in there, I think probably because they've got the treble and bass controls in here as well, and the microphone coming in here, I think this here is probably using a small amplifier circuit, which is then fed into the main amplifier circuit to clean it up so it can go out to the headphones itself. And that's probably why this is quite good. I mean, it's made for a hearing, you know, to help somebody hear something like the television, but they're not quite deaf enough to have an hearing aid yet. So it's only a small microphone, and the hole for that microphone is also very, very small. So I think that's what's going on here. We've got a amplifier circuit here fed into the main amplifier circuit, cleaned up using the bass and the treble, and that's how they're doing it. And I presume that's why all these capacitors are on here, just to clean that signal up. So what I'm going to do now then is cut away the part of the case that we don't need to keep this battery holder in place, and then I'm going to take a look at the project box and try and figure out how I'm going to wire all this up. So now that I've had some time to think about this, I'm going to keep the treble and the bass, and what I'm going to do is drill holes through the project box there, and I can use these knobs here, put them back in place to control the treble and the bass, just so you know it's not so piercing with some of the high frequency sounds it will pick up, so you can turn that down a little bit. I'm still going to override the volume and on-off switches on here, so I'm going to be mounting this circuit board over to the side here. So this new volume control here, I can drill a hole through the side, and there's plenty of space inside the project box then to wire that up. I'm just going to leave the one in place on the circuit board and just override it with some wires, so this will then control that. And same with the on-off switch, I'm going to mount that onto the side there, and again override this, because you can see it's built into the volume there, and it'll click and make contact there and there. So all I have to do is wire a couple of wires, solder them in place here and here, and then have them running out to my new switch, and that will just override the control, so we don't have to remove that. And same with the new pickup here, that's going to be soldered onto the microphone here. I can leave the jack plug in place, I don't need to desolder that, I can just override that by soldering onto the solder pads here through this side of the board. So pretty simple really, and even with this potentiometer in place, I've still got plenty of space there for the single AAA battery. Now you may be wondering how I'm going to drill the two holes so they line up with the treble and bass controls here on the circuit board. And you could put some masking tape on the inside, get a Sharpie and load up plenty of ink onto the top of those, and then press down, and hopefully, fingers crossed, you'll leave an ink mark on the masking tape, so then you can drill through. But what I'm going to do, I'm going to use the case as my template or jig, just place that down on the inside, and then I know exactly where to drill there for the two holes for the treble and bass, and then they will line up of course. But I'm just going to trim away a little bit of this case here, just so it's more snugly on the inside wall of the project box, so I've still got plenty of space on this side. So that's the treble and bass in place, and it's turned out rather well. And because I've used this as the template, it's not bent in any way, and I do, when I'm designing something, I really do like symmetry. If something's a little bit out, every time I look at it, it will bug me. But I haven't fastened the circuit board permanently in place yet. What I'm going to do now is drill the hole for the potentiometer, and drill the hole in the side here for the on-off switch, and then I'll show you how to bypass those. Really simple modification this, and a nice little project you can do with your kids. So here's a quick look on the inside of the project box then. Now I've drilled all the holes and I've decided where I'm going to fix everything in place. I haven't wired anything up yet, but it's just to give you an idea of my way of thinking. Now first of all, for the switch, I decided not to use a switch I'd just shown you previously. I've used this switch instead, purely because it's just as simple as drilling a hole through the project box rather than trying to cut out a rectangle shape. And what I've also done is I'm putting a LED in line with the on-off switch and the power, just so that we know when the unit is switched on, that's all. Because the entire thing runs on 1.5 volts, I don't need to put any kind of resistor in line with the LED to knock the voltage down any. Now as for wiring the on-off switch up, what I'm going to do is just solder a wire here to this and a wire here to this. What would normally happen is when you rotate this wheel, these two click and come into contact with each other to power it on. So I'm just going to leave everything in place and just override that with this switch here. So this switch will be in control of that, and when we've got power connected in to the switch, it will just power on the LED. So it's just a simple on-off LED. Now as for the coil pickup wire, I've drilled a hole in the top of the project box there. I'm just going to feed the wire through there and just desolder the two wires for the microphone here, and then just directly solder the coil pickup onto those two solder points there. Now as for the speaker, I've epoxied it to the top of the lid of the project box, and I'm going to solder on 2 wires to this, quite long, so we can easily remove the project box without ripping the wires out when we want to change the battery in here. And I've decided to use the flush fitting one just because I'm going to have the battery pack under here, and you know, I've now got the switch in there as well. I could have fitted the other speaker in there, but it would have taken up a lot more room. And I've just epoxied it in the corners, as you can see there, and just drilled one single hole through the lid of the case there, just to let the tones come through. Probably would work without drilling a hole. I mean, it can get quite loud, this, but just one hole is sufficient enough. I find that if you try and drill more than one hole, unless you get it, you know, lined up perfectly, it can look a little bit messy. So I'm soldering everything up now, and I've soldered onto the volume control here the green, white and black wires, and just extended those out over to this one here, just so it can override this on here. Now, as for the power, this is the positive lead that's going to be soldered onto the positive of the battery terminal. This then goes from the switch here onto the positive of the LED. This positive wire then goes over here, and it's soldered to this here. Originally you had your positive coming from your battery terminal here, and that was connected up to one of the metal levers on this side, and then the metal lever would come over, make contact with this, and then power onto this here. So what I'm going to do is bypass all that. I've also removed the spring off the little gate here for the power switch, just to make sure it never accidentally closes again. But I'm just going to take this power here, this red wire here, from the LED over and solder it onto this terminal here, and then that will power on the unit when the switch is powered on here. So it'll just connect those two over, so I can do away with this red wire here altogether now. And this is the ground wire that will go directly onto the battery terminal, and this ground wire here on the LED will just be soldered in line with this one. So the power here, the positive, will control the LED. The ground will be permanently connected to the ground on the battery. So I've just got to finish soldering this up then. I've got to solder this wire over onto here, desolder that, get rid of that, fit everything in place, then resolder the battery compartment up, and then basically put everything back in place, and then finally solder the pickup coil directly onto these two terminals here. So I've got to desolder this and get rid of this. So here it is, all finished inside of its case. Then there's one thing I did do wrong, and it's one of those things where your mind gets ahead of itself, and the LED here, there's not enough power, just because you know, we've got a single AAA battery. There's not enough power to power the LED and the amplifier unit at the same time, but I'm pretty sure that you could run this amplifier on 3 volts, no problem at all, and then you'd have enough power to power the LED as well. But for now, the LED doesn't work. So let's get a few things on the bench then, so you can get an idea of the kind of EMF that this will pick up, the different tones and everything, depending on, you know, where you position the pickup coil relative to what's operating on, say, a laptop, for instance. So let's take a look at the different sounds that this can pick up with a typical laptop. This is my laptop that I use here in the lab, so it is rather dirty, but it is fully functional, connected to the internet at the moment. And remember that this will not pick up high frequencies, it's only low frequency electrical stuff. So let's give this a go then. So I believe that is the fan for the laptop just there. The hard drive is over here. This is the mouse. And over here is the charging circuit for the battery, and the processor is around here somewhere. if you play around with something like this, you can really figure out the different components and the different tones that they make. The memory should be in this area somewhere. The LCD is also pretty noisy in places. So this is the speaker here. Back over the processor and memory, and back to the fan again. So you can really get an idea of the different components and the different sounds that they make. This is one, I mean, it's not really a practical tool in any sense, but if you've got children, you know, it really is something that they will get into and discover the different noises that different things make, even around the house. An LCD TV, for instance, makes a lot of noise. A plasma TV, if you've still got one of those in your home, that makes a hell of a lot of noise. And you know, different things, it really can be interesting, especially for children. And here's my soldering iron, and it makes different tones when the LEDs flashing. LEDs are particularly noisy components, so let's give this a go then. You can pick up the transformer, but you can see when it's sending that burst of power to the transformer there, or should I say you can hear, and you can correlate that to the LED going on and off. This is my second soldering iron, and you can hear that it makes completely different noises to the Heiko soldering iron. If I put it back to the Heiko, and that would be the same with a TV or LCD monitor. Even though they're both, you know, two LCD monitors, different makes make different tones depending how that circuitry inside is built and working. And what I've got here is a broken tablet. I've removed the back so we can see the different components. So let's give this a scan then. I'm just powering it off the bench power supply here. But something like a tablet will make different tones as it boots up. You know, whether different components on the motherboard are starting up at different times. So I believe that down there is the charging circuit for the battery, although there's not a battery in there. Certainly the power supply regulating the power coming in from the bench power supply is there. And under here is the main processor and memory. I believe that this is the GPS, Bluetooth and Wi-Fi chips under here, although I could be wrong. This is my phone, and as you can hear, it's not doing a great deal at the moment, but watch what happens when I turn the LCD screen on. Suddenly it starts making all kinds of noises, and then when it goes off, it goes quiet again. So a nice interesting project you can do with your children, you know, to get them interested in electronics basically, and you know, the different noises that electronics make that you can't normally pick up with your hearing. Electronics are extremely noisy things, and they'll be surprised the different noises that they do make, and I mean, it's just thankful that we can't pick them up with our hearing, otherwise they'll probably drive us crazy. As I said, I made this. I made one of these many years ago. I ended up giving it away to one of my students who was borderline autistic. He found it absolutely fascinating, and his mother told me it kept him quiet for months and months. But you know, it is a fun little project. And you can make this as hard or as easy as you like. I mean, you don't have to put it in a project box like this. You can buy amplifiers on eBay, little amplifier kits even, put one together yourself, and then the main thing you really need is one of these pickups that are, again, pretty cheap off eBay. A couple of pounds, you can get one of these. So you could build something like this complete for, well, easily under £10, if not even cheaper. So if you did enjoy this project, as always, please give it a thumbs up. Any comments or questions, drop them below. I'll do my best to answer them, and hopefully you'll join me on the next one.